Hi guys, we're starting on the North Carolina Math 3 released items. I've numbered this 28 for our notebook, and we're going to start off on the front with the gridded response, and then we'll flip over for the multiple choice. So on the front, the first question says, what is the remainder when x cubed minus 1 is divided by x plus 2? So x plus 2 is my factor that I'm dividing by. There's actually a little bit of a trick here. When it just asks for the remainder, there's something that you can do to find the remainder that does not involve dividing. So you don't have to go through all the steps of dividing. If you can't remember this trick, then you can divide and you will get your remainder. But this is just a quick, simple, short way to get this done. So I know that x plus 2 is a factor, and we know how to solve factors. We just set the factor equal to 0 and solve. So I know this ends up giving me x equals -2 because we've gone through changing the sign. So if I have x equals -2 as my x value, I can actually take the x value, x equals -2, and plug it in for this x value in my equation. So I'm going to replace the x right there with -2 and then simplify. So -2 to the third power is -8. Because I have negative times a negative is a positive times a negative. And then I have -1 because of the -1, and I get -9. So my actual remainder, my actual solution is -9. So that's the answer. That's all you had to do. All right, then for problem number 2, still gridded response. It says the function below has x minus 7 and x plus 4i as factors. And it gives you this long equation. And then it says, what is the total number of real zeros of f of x? So once they just know the real zeros, pay attention to your vocabulary as you read the state test questions, because I obviously have some imaginary zeros in here because I have this imaginary zero written up here. It's not really asking me about the imaginary zeros. So you can use Desmos to figure out how many zeros you have, real zeros. We know all together, real and imaginary, we should have 5 because my exponent is a 5. So I can use Desmos and type in my equation. So 2x to the 5th minus 13x to the 4th. Oh, not 13. Plus 22x cubed minus 187x squared minus 160x plus 336. So when I graph it, I can see my zeros. And if I zoom out, I can see that there are only those 3 zeros. And remember, you always get your calculator. So this didn't actually ask me for the solutions. I can make a note up here for you that our zeros are -1.5, 1, and 7. But really, it's only asking me how many real solutions there are. And because there are 3 x's, there are 3 real solutions. So real solutions are the ones you can see on the graph. So my actual answer is that there are 3 because these are the 3 real solutions. If they ask me how many imaginary, I should be able to figure that out pretty simply because I can count how many real on my graph, and then I can subtract that from the 5 that I should have in total. And so I know if they asked me that I'd have 2, I'd have 2 imaginary. So my actual solution to this one is 3 real zeros. All right, so we're going to flip to the next page, the next side. All right, so here's my the release items that are multiple choice. The first one says the graph of the function m of x equals x cubed plus 3x squared minus 2x minus 4 has a 0 at -1. what are the other zeros of the function? So you can use Desmos to graph the function. It already tells us one of the zeros. Whoops. So here's the equation. It's x cubed plus 3x squared minus 2x minus 4. And I can see these are my 3 zeros, and I'll make a note over here. We already knew the -1, so I'm just going to go ahead and like check that one off because it wants to know what the other 2 zeros are. So I can clearly see that the 2 zeros that I don't have are not A and B because they have whole numbers and I don't. And then I also have C and D that look kind of funky. So you can test out C and D using Desmos. So I could type in -1 plus the square root of 5. And I can also do -1 minus the square root of 5 and see what those decimals are and if they actually match the 2 that I'm trying to find. And if they don't, I would move on to test part D. So let's see what we get. So I'm going to type in -1 plus the square root of 5. So I get 1.236. Oh, that's that one. So here's this one. And so if I change that plus to a minus, I do in fact get both of my solutions. So C is my answer. You could type in the numbers for D, but we already know that they're not right. So I'm not going to type them in up here. And then if you move on to number 4, it says which expression is equivalent to, and it has 2 trinomials. We haven't done a division this long, but it's just like you've been doing. So I'm going to set it up in the same manner. I'm dividing this first one by the second one. So the second one goes in front of the first one, which is inside of my division symbol. And then the questions that you ask yourself are the same. You just have to go through 3 values instead of 2. So I have x squared times something is going to give me x squared. That's pretty easy. It's going to be a 1. So I have x squared times 1 is x squared. You have to remember that you also multiply each part of the equation to the left of the sign by that 1. So I'm doing x squared minus 3x minus 40 times 1 and writing it down. So I get x squared minus 3x minus 40 because I'm just multiplying that to the left with 1. Then you have to remember to change your sign. So I'm going to go through and change all of my signs because I have to subtract. So when I do that, these go away. I'm left with an x here, and I'm left with a 3 here. And it is positive because I have a positive 40 and a negative 37, and 40 is a larger number. So if you look off to the left at your answer choices, you can see that C and D don't make a whole lot of sense. They just have 2x minus 37 as their remainder. They are counting on you forgetting to multiply the negative 3x and the negative 40 through, because if you forget that, then you'd be left with the 2x and the 37 as your next part of your solution. So I know that C and D don't make any sense. And so now I'm looking at A and B. When you write the equation and you write out the remainder, the answer comes first, like the 1, and then you always add the remainder. So x plus 3 is my remainder, and it goes over the polynomial that's out front. So my solution looks like this. You'll be adding whatever your remainder is. So my answer is A. I'm adding on that remainder. All right, and then the last question, number 12, says a polynomial p of x has a leading coefficient of 1 and exactly 3 distinct zeros. So the fact that it tells me the leading coefficient is 1 just means that there's not going to be like a number out front of all of my factors. So it tells me that it wants me to write it out in standard form. It doesn't say that, but I can look at the answer choices and they're all written in standard form. Because they gave me the x values and their multiplicities, it's really easy to write it in factored form. And then we can kind of use Desmos to cheat to find the standard form. So if you actually read, it says x equals -1 is a 0 of multiplicity 2. So this information right here, the multiplicity part, is very important. So I know that I have x minus 1 twice. That's the only one up here that says 2. X equals 2, multiplicity 1, x equals 4, multiplicity 1. So I know that I have 4 total zeros because I have 2 that are -1, and that's where it bounces on your graph. And then I have 2 that are just multiplicity of 1. So when I add that up, I get 4. So I know by looking at my answer choices that C and D are not possible. I mean, the A and B are not possible because they're only cubed, and I actually have 4 zeros. They're counting on you not knowing what multiplicity is here. So if I write this in factored form, my first one with the -1 is x plus 1, but it has a multiplicity of 2. So you can write it as x plus 1 times x plus 1. Or you can write that as x plus 1 squared. It doesn't matter, but it's one or the other. And then my next one says x equals 2 is a 0. So we always change the sign. So I have x minus 2. And then for 4, I have x minus 4. So if I actually wrote p of x out in factored form, I'd have x plus 1 times x plus 1 times x minus 2 times x minus 4. Now I can clearly see what it is in factored form, and to multiply all of this out to get it into standard form could be a long task, but you get to use your calculator all the time, and I would use it to your benefit. So if you pull up your calculator, I can type in my factored form. So x plus 1 times x plus 1 times x minus 2 times x minus 4. All right, so I can clearly see that these are my zeros. These are the same ones that I had, but that's not really what we're here for. So I can look at my graph. I can see what it looks like. I can see how far down it goes, how far up it goes. And we can graph our possible solutions. If you're not sure about what the degree is going to be, then you could type in like A and type in the equation here. I'm already telling you that it's not going to be A and B, so I'm not going to test those. But I'm just going to start typing in C or D, and I'm going to type both of these in so I can show you what the correct answer looks like and what a non-correct answer looks like. So if I type in the first one, I get x to the 4th minus 4x cubed minus 3x squared plus 10x plus 8. And then if I type in D, I have x to the 4th plus 4x cubed minus 3x squared minus 10x plus 8. Oh, I forgot my x right here. It's like something's not right. All right, so if I turn this one off, I can see the green one is my factored form, and the black one is the last one. The black one and the green one are definitely not on top of each other, and that's kind of what I'm looking for. I want to see that they match, because if they're the same equation, their graphs are going to match. So number 2 on my graph, which is C, I turned off. So I can see that D does not match on the graph. But if I turn that one back on, my purple one and my green one are right on top of each other. So I can see that my actual answer that is the solution is going to be C. So my actual solution is C for that one. Make sure you put these in your notebook because when you get to take your quiz, you're going to be able to use your notebook and I might ask you something similar. Tomorrow when we come into class, I'll answer any questions that you have. But we are going to move on to the beginning of our next topic in polynomials.